with your dog. I hope you had a good conversation with your dog. Bow, bow, bow. I don't know. Why did you guys talk? And he's asking whether every complex number question they give, or almost. Like if you go back, there is one part where they give you a sketching to do, you know, like in this second question, it's not exactly that type, but you have some drawing to do. Show on a sketch of an Argand diagram with origin O, the points A, B, C, representing the complex numbers, this, and Z respectively. And then, so it's not to shade a region satisfying a condition, but just to sketch these points, and then state an equation relating the lengths OA, OB, and OC. Just 1 mark. You can try that later. It's not exactly what the type that we are doing, but it's some drawing to do, right? But I will leave that. I will just look for. Now here you go. This one. And this, yeah. Shall we do these two? Okay, you have to do part 1 as well, because you have to find U. You need U. I'm sorry, now I don't like when they use the letter U for this, because when I say U, you might, because I also say U, Y-O-U. Confusing. Okay. First you have to, do this whole question. Quick start.
Question number 4, 2003 of November.
Everything. Part 1 is 7 plus 4. Divide, it's division. You have to just work it out and write U in the form X plus IY. Okay, Hatvi has the answer. Okay, you have gotten the answer. I will just write it. So it's 1 plus 2i. I didn't do the simplification in full. Yeah, looks like. I hope this is, 1 plus 2i, right? U is 1 plus 2i. Then sketch on sketch an Argand diagram showing the point representing the complex number u. Show on the same diagram the locus of the complex number z such that z minus u equals 2. Z minus u equals 2. Equals 2. So I think I could do better. Let me try. I just draw a circle and then place it there. Yeah, that works. Something like that. And then it's the next part. So it's just the circle here. And the circle has to actually come this way a little. Like that. So the radius is 2. Okay, the radius is 2. Now, what do they say next? Find the greatest value of arg of z for points on this locus. So points on this, the locus is a circle. Find the greatest value of arg z. Which z on this circle would have the largest argument? Largest argument. Yes, Hasti, you can give the point. Can you put that to everyone? Let's ask the audience. Are they asking for the, let me look at this again. Come on. Find the greatest value. You have to find that angle. Okay, let's find who the Z is and its angle, its argument. You have to find that find the angle. Find the angle. Find the angle. Hatfi is not giving the angle. Hatfi is giving the Z who has the greatest angle. Is that right? Can you show me in the, like, how would you draw it in your diagram? Now look at this. For the argument of a Z, now your Z, where can your Zs be? Your Zs can be on this circle. Think of all the points on this circle, okay? Argument is like, now for a Z here, that's the argument. For a Z right here, that's the argument. For a Z here, that's the argument. For a Z here, that's the argument. I mean, argument means think of the angle between the positive real axis and this line that I'm drawing. For a point Z here, that's that angle. Now I'm increasing the Z. Can you see I'm increasing the Z, I'm increasing the Z, I'm increasing the Z, I'm increasing the Z. Hatfi gave me this point. That this corner point, -1 + 2y. But if I go here, isn't that argument greater than this one? Isn't this greater than this one? So the Z sitting where has the largest argument. The Z sitting where? If I draw the tan, like the Z sitting right here, wouldn't it be? Oops. If you draw like the tangent, the one right here, that has the greatest argument angle. It isn't covering the circle? What do you mean covering the circle? It's on the circle. The one here, this Z. I'm talking about this Z. So we don't consider the others. What do you mean? Like for any other Z, say your Z is here, then that argument will be smaller than this. So I have drawn the largest argument. You don't get it. Okay. Yes, I will explain it again. Should I draw this in a new one, a little bigger? So I didn't mean to draw red, but it's okay. No, that's not how it should be. It should be that. Like this, I think, okay? Then that's your this is 2. So this point is 1. This point is, this would be, I'm just showing you points. This is 2, and this is, I'm sorry. Oh, that's terrible. No? This is -1. I mean, it's not very accurate, but it's fine. And this point for the upmost point here, this would be this is I now, this is 2I. Is that right? No, that's not right. That's 2I. Oops, sorry. This is 2I. And then that
4i.
should be 4I. Sorry. Thank you. 4I. Right, my points are right now. Are they right? Okay. Now, my variable complex number Z can be anywhere on the circle. Now I have given the locus of this Z. My Z can be anywhere. What was my condition? Z minus U is equal to 2. Satisfying this condition, where can a complex number be? It can be anywhere sitting on the circumference of this circle. So think of all the points on this circle. Now think the arguments of these points. Like if I draw different arguments, let me draw arguments for a couple of different points. Remember, argument means you just connect the point from the origin. So that's here's one. Okay, here's another one. Here's a one for right there. Here's one for right there. Now argument means this angle, little angle. This is a little small. This is bigger. This is bigger. This one is even bigger. I am looking for the Z who has the largest angle, largest argument, right? Okay, Malit. So you have to see that I have to go for, I can go like if I draw which one will have now the one Hatfi thought it's the one right here. Let me draw that argument. That would be that. Okay. Yes, true. That is big. But for a point that is somewhere here, the argument would be greater than that. So which one would have the largest argument? You have to see. You have to realize that if the furthest I can go is for a tangent, like the one right here. For the one right here. This one. Let me draw the argument of that in a different color. I shouldn't have drawn in red all of these. I'll draw it in there, that one. So if I just extend that line, just extend, okay? I can extend that line, there's no harm extending the line. It's the tangent, do you see that? There you go, it's a tangent. So the point is this point. This is the Z. Z, who has the largest argument? Who has the largest argument? And they're asking what that argument is. What is this angle? What is this angle? How much is that? So some geometry that you can make use of is you have a circle here of radius 2, and this line is a tangent. So if I now erase all these unnecessary ones, and you remember circle, you need some previous knowledge. You remember circle theorems? This line, I'm going to make a right angle triangle here. I don't know whether this, would I need that? This is the angle I want to find, okay? I don't know, can you, let me not, I'm not sure whether that was a bad idea that I drew that, but you know, this is a right angle triangle right here. This is the radius. Maybe you don't need that. Can you try to find this angle? I don't think you need that because this is 90. Okay, can you find that angle? This angle, okay, this angle. Because that's the argument for this point. Okay, anyway, shall we do like this? Because it's, oh, it's 8. I was planning to discuss the P3 paper. Are you all ready with it? Let me know what your choice is. Would you like to do a few more similar questions on complex numbers and just get this done with? Or will you all be okay to just give this a break?
I agree with Mihir and Malit.
Okay, yeah, no, so since we are on this now, let's just encounter all our demons in this topic and then learn how to deal with them. We can do the P3 paper tomorrow. Yeah, we can do the tomorrow. Yeah, then let's do like that. Okay. Now, you understood. Have you not done the paper, Malik? Anyway, now you understood how we figured out where this Z, who has the largest argument, is on this circle. Now, finding this angle is another question. It's just geometry. Can I leave that for you to do for like without using our time from to apply the complex numbers knowledge? So this part, to get the answer, I'm letting you use your own time at home. That's a little bit of homework then. Okay. So let's look at another one. Now, Malik, this 5th question doesn't have a sketch. This also, it's not the type that we are doing, but you have some diagram going on. It's just to plot the points and show that this angle. I think you can manage those. We will just look at let's do this.
7th one.
7 part 3.
No, it's 8. It's question 8.
Sorry, number 8 part 3. Yes, number 8 part 3. Do we have everything, all the information? Sketch an Argand diagram showing the point representing the complex number 1 plus 2i. Show on the same diagram the set of points representing the complex numbers z which satisfy. Okay, yeah. It's 4 marks. Okay, it's 4 marks. But when you see it, you have to know what is this related to? Is it a circle thing or is it a perpendicular bisector thing?
Circle. I believe so.
Do you know how to recognize?
No, it's not a circle.
You have modulus 2 moduli. It's about a perpendicular bisector. But yeah, yes, it's bisector. Okay, quickly do it. It's easy. This means distance from Z to 0. Okay. You have to identify the two trees, fixed points. One is 0. One is, if you put a bracket here, 1 plus 2y. Bracket here, 1 plus 2y. That's easy. That's easy. That's easy. That is easy. Oh, Hati. No, I left it for homework for you to like. It's just geometry. Now you know now where your z is. You just have to find its argument. You do that for homework. And then we started this one. This is question number 8, part 3. And let me just erase all these things I've done here. Done? It's quite straightforward. Done. Okay, let's see. Number 8. So first, if I write it in this way, z minus what equals z minus what? This is just 0. This is just 1 plus 2i. Those are my A and B. A and B. The two trees on the so one is at 0. One is at 0. This is A. The other one is 1 plus 2i. 1. This is 1 and this is 2. B. So it's a line connecting. First connect the two and draw the perpendicular bisector. It's the equal. So it is the perpendicular bisector. It is the perpendicular bisector. The green line is your locus, or all the points that satisfy this condition. Your z has to be equidistant to both A and B. The distance, this means distance from z to A must be equal to the distance from z to B. So equidistant. It's the perpendicular bisector. Got it? That's okay. Let's look at another one. Shall we do these two? Because we have a similar thing there, using your diagram, calculate the least value for modulus of z for points on this locus. Like, oh, but you have to do the first part because you need u. You need u. Can someone quickly find u and let us know? Oh, can you show the diagram, the one you drew? Yes, sure. This is part 3. And just do this to show that they are equal. Okay, Hatri. First find u because you need it to do part 3 and 4. Find the complex number u plus I divided by 2 minus I.
Miss, what year is this question again?
Oh, 2006, October.
And
What's u? Did you find u? What is this equal to? 1 plus I. Thank you, Netni. This is 1 plus I. So now you can do part 3 and 4. Sketch an Argand diagram showing the point representing the complex number u. Show on the same diagram the locus of the point representing the complex number z such that z minus u equals 1. Is this something to do with the circle or a perpendicular bisector?
circle.
Very good. Let's calculate the least value of z. Z minus equals 1. I That's U. This is 1. Radius is 1. Now, using your diagram, calculate the least value of Z 4 points on this locus. Out of all the Z's here, what's the least Z? Least modulus. Who has the shortest length? Least. So your Z's are on this line. Which one has the shortest? Can you show me where that point is? Who is closest to 0? In other words, the distance from 0 to Z must be the smallest. Modulus. No. Can you draw that the distance? Can you show me where that point is? I think you were trying to show me this point. Yes, that's right, Nathan. Good. This guy has the shortest. He has the shortest or the least. He's the closest to. You have to find that now. Again, that's geometry now. Find that distance. Finding this distance. I hope you can see a symmetry. Like this is the exact midpoint. Like it's 45 degrees here. It's a diagonal line. So how would you find that distance? That part also, can I leave for homework? Finding the distance. In the earlier one, finding the angle to that Z, I left for homework. Here, finding this distance to this Z, there it was the largest argument. Here, this is the shortest modulus. Both, because it's just, you just need to like zoom and draw it, redraw it, look at the lines, some geometry, use geometry and find that, okay? Oh, wow. This one looks good. But again, you need U. Can you find this?
Yes.
You are doing number 11. First find, this is U. Find that U, 2 over minus 1 plus I. Oh, Malit is asking, in a circle, the largest argument is the line that makes a tangent. It depends on where the circle is, isn't it? Like, let us see whether that's whether we can come to a general conclusion like that for any circle. It's going to be a tangent. That's true. It's going to be a tangent. Like you have to know where the like. Can I go to the? Okay, say you have. Let's think of different. Say you have a circle here. Say you oops. Say you have a circle here. You have a circle here. So you have a circle here. So you have a circle here. Wherever the circle is. So for each of these circles, for the points on these circles, for this circle, circle A, circle B, circle C, circle D. For circle A, the the z who has the least argument would be the tangent. Yeah, it's always a tangent. This one right here. This has, oh, what happened? Did you?
Yes, can you tell me the definition of an argument again? Like, can you explain it? Because I think I can't like.
Argument of a complex number is the angle between if you are talking about an angle, there must be two lines there because an angle is always between two lines. You need to have two lines, right? Two arms. So what are the two? This is argument means an angle. What is the angle? Argument of Z is the angle between, here's the first line, the line joining Z and 0. It's like you draw the, it's not a bracket. And it's like the position vector drawn to Z, that line, okay? And the positive real axis. So that means if you have a Z here, it's this angle. If you have a Z here, it's either this angle or you can go negative side that way. Usually we don't, yeah, I mean, they will tell you how to define, you can give it either way, as a negative angle or a positive angle. If your Z is here, you draw this line, that's the argument of that Z. If you have a Z here, that could be the argument of that Z. You start measuring from the positive real axis. From that axis, you go positive direction, negative direction, in any direction up to the line connecting 0 and that Z, whatever that Z is. Z is here. This is your Z. Okay, Malik? Okay. So coming back to this, on the for all the points on this circle, on circle A, this is the Z that would have the least argument. And this is that one right here. This one right here. This is the Z who has the largest.
Excuse me, miss.
Yes, Malik.
So, miss, in any situation like a circle connecting to the origin, the largest and the least argument value is made with the tangents that it can
That's
form.
correct. That's correct. Yes, that's correct.
Okay, miss. I kind of lost the definition of an argument, and then I didn't get the whole idea. So that's why I asked.
Okay, now clear. Like for all these circles, I'm drawing the smallest, oops, and do you see that? And for circle Z, sorry, for circle D, like that. Okay. You're welcome. So where were we? I forgot. Oh, you're finding the U. Did anyone find this U? -1 minus I. This is -1 minus I. -1 minus I. You need U squared also because you have U squared here. U squared, you have to square this. So U is -1 minus I. Tell me what U squared is. U squared. Is it 2? Two plus 2y, something like that.
Miss, you're asking what is the U squared?
Yes,
2y.
just
Just
2y,
2y. Just 2y.
not 2
Because
plus.
when I cancel out the brackets, it comes as
I
1
think it
plus
is 2 plus
y.
2y. Yeah, Nitni says 2 plus 2y.
Yeah.
Check that again.
Okay. Check again.
It's 1 plus 1, so it gives you 2. 2 plus 2y. Now you can do the sketch.
Miss,
Yeah.
hold on. Minus 1 into minus 1, that makes plus 1. Then minus 1 into minus I, that makes I. Then minus 1 into, then minus I into minus 1, that makes I. Minus I into minus I, that makes I squared. So 1 minus the I squared equals I squared is minus 1, no, miss?
Oh, it's 2y.
So that was, I was wondering how that became that way.
Nitni, is that right? It's 2y. This eraser is not a good eraser. It doesn't erase well. Come on. Okay. Okay, so it's just 2y. Thank you, Nathan.
You're welcome.
Right, now do this one. Is this a circle or a perpendicular bisector?
Is that a circle? That's a perpendicular bisector.
Yes.
Yeah. Two.
And it's one side of the perpendicular bisector because it's an inequality. If you had the equal sign, it's the perpendicular bisector. Now here, you're closer to one point than to the other point. So your U is square. So y. This is your A, this is your B. Two y. Minus 1 minus I. Connect them. And your answer is I mean my like perpendicular bisector. Oh, there is a circle too. Where? Were there two conditions? I did not see that. Oh, wait. Shade the region whose points represent the complex number z, which satisfy both inequalities, this and this. Oh, this and two. One is, other one is, oh, wait. So where is that? Two. Where is two? Two might be right. Two would be right somewhere here. It's two. Oh, it's not two. It's the circle two. So, does this line pass through the origin? Does this green line pass through the origin? I don't think so. No, I don't think so. So to draw a circle around 0. Like that. With radius 2. I go. Oops, no. I have to be, so according to this, I have to be where? I have to be in the circle, inside the circle, and also according to this, I have to be on which side of the perpendicular bisector? On the side of, this is A, this is B, on the side of A. Ah, okay, Malit. Yeah, they are all the same things. Yeah, so they give combinations of these things. So I have to be inside the circle and I have to be on the side where A is. I have to be closer to A than to B. Closer to A. This distance is smaller. So I have to be closer to A. That means on the I have to be on the side where A is from the perpendicular bisector. And I have to be inside the circle. That means, and these things have to be dotted. Dotted. I can't. That's correct, Malit. Thank you. Oh, I will use a different color.
Miss, is it the bisector that has to be dotted or?
Both now here. I don't have the equal sign for both of the
Ah,
conditions.
the circle also, right?
Circle
yeah.
also. So
Okay.
I think I should draw the circle by hand. Let me draw it by hand. Because it's, oh, did everything like go away? It's difficult, but I will try to draw the circle like that. Oh, that's not bad. And then even the green line should be dotted. Okay, you keep your rule and draw. And now the final region is this. That is it. Understood, everyone? Is this clear? Now for the next one, I'll give you now, we'll go to the next one. And for that, we will do like this. You have to completely do it on your own. And you would take a picture of your sketch and send me. Shall we do that? Let's go to the next one. I want to pick a hard one. Why is this not going? It's not going. Oh, oops. We should do full questions. Okay, but okay, do this part. Question number 19. Again, you need to find this. Oh, you need to find A also. No, you don't need any of that. You don't need any of that. You don't need you. Just do part B. Just do part B. This is question number 19. Both inequalities and this. Yeah. Okay. Just do part B. Okay. I'll switch off my video. You just do it all by yourself. No help from me. And you send your sketch. Take a little picture, photo, and send me on the WhatsApp. Or what? How can you send it to me? Or in the chat. WhatsApp. No, I can. It's easy for me to check on the WhatsApp.
Person message or the group one? Best person, no?
But I would like that's
Everybody
true,
see it.
because if you okay, let's do like this. Till everyone is done, don't start sending. So do it and take your picture and keep. Once everyone is done, I will tell you now send it. So then you all send it to me on the WhatsApp.
Okay.
Okay. So no one is spoiling anyone's thought process. So you do it
Miss only B. We do only B part, right?
Only part B. Only part B. They are independent. Nothing to do with part A. Just part B. Okay. In the chat box, you say done when you are done. And then when everyone is done, we will start sending. No one is done yet?
I think I am done.
Okay, okay. So drop a message in the chat box saying done so that I know who and who is. Mom, not at home. So how do I? What do you mean? Oh, you don't have the phone. Then, yeah. Then you send. Can you send in the chat box then? Can you send in the chat box? No, can't. No? You can't take a photo. No? You can take. No, there's no way. All right. Okay. Yeah. It's okay, Hatvi. Whoever who can, you guys send me.
Shall I send you now, miss?
Yeah. Okay. So Nathan has sent. Yeah. Okay, Hatvi, you can do that.
Am I right?
I'm checking. Wait. That's right. And then. Where is your 2 plus 2 I point?
Miss, do you want me to mark them? Because then it's a DC for you then.
Because
I know. Then, miss, let me label. I am not labeled in the equation A and B. Shall I label it?
So anyway, it's partly correct, partly wrong, Nathan, because your second inequality. Now this one, okay, this one has to involve what? Wow, this one involves what? A circle.
Yeah, a perpendicular bisector.
You don't even have that in the diagram.
I'm sorry. I just spaced out there. Sorry.
I got you to do it on your own. So now what I can see is that now we did a couple of examples, similar examples.
No, this one I was in a hurry. I was like, so be the first one to send.
Okay. Okay, Netni done. Netni, did you see? Let's see. Okay. This is 2. Correct, Netni. Very good. Yes, Nathan. Only
That is
thing,
correct.
yes, it's correct. The bisector also has to be dotted. That's all. Then correct.
Oh, okay.
Has to be
I mean,
dotted.
should the points also be like the AB line also, should that be dotted?
No, let that be. You have
Uh-huh.
like it's there to aid you to find where the perpendicular bisector. No, you have to connect A and B to draw in order to draw the perpendicular bisector. That is just there to help you to get there. And then I mean you can even erase that line if you want. But
Okay.
keep it so that the examiner can see how we have approached our final region.
Okay.
Yes, Malit, you can you can send it to the group. Now Nathan and Nathani have sent and their answers are right. So I can actually, instead of doing it myself again, I can just share one of your answers actually. Malit, you send yours, and then Hatfi can just, Hatfi, it would be difficult for you to like say it, no? I'm sure. That's correct. Yeah. Correct. Let me go to this and get this one. And then I'm going to correct. Malit, you're correct too. I will show you Nathani's. Here it is. Okay.
Wow, she took the liberty of coloring.
Yeah.
Nice.
And I mean, these circles are perfect. How do you draw your circles? Even Malit, all of your circles are way better than my circles. My circles are like, yeah. Okay. Anyway.
Here's a secret, miss.
Shall I tell you the truth?
No.
This circle, I didn't draw it from the compass this time, and I think this is by far the most perfect circle I can ever draw in my life.
The one you sent?
Yeah.
It has come up.
How did you do it, Malit? How did you do it?
Just by free hand. Okay, anyway.
Freehand drawing.
Yeah,
Oh,
that's the best freehand circle.
Can we quickly look at one more question?
Okay.
Okay, one more, last one. This one, part B. Quick.
Okay, quick.
Greatest value of argz for points in this region.
Question 2011.
I can show you Malit's and both Nathan's. This is Malit's. Not bad, eh? The circle is nice. And then, oh, you all can see Malit's because he sent it to the, I forgot. Here's Nathan's.
You can't see my lines because I didn't use the pen.
Yeah. And the bisector has to be dotted. Nathan, please make that change in your answer.
Yes, I did. I just did that.
Okay, number 20, part B. Again, you send the answer to me, okay? I'm on mute. Happy, are you done? Can you send me now? I mean, this part is easy, isn't it? Why is it taking so long? Okay, let's see, Nathan. Very good. Yes. Correct. Nathan is correct. And he has also shown me the Z that has the greatest argument, and that is correct too. Nethni, yes. Nice. Yes, that's correct. Yep. Yeah, so how to find this argument? I left it for now. You can see that they ask you the same thing, right? Similar questions. When you have shown the possible positions of a complex number satisfying a certain condition, when it is a circle, how to locate the Z who has the largest argument or the smallest argument or the largest modulus or the smallest modulus. All these are connected, and how do you find them? That is geometry. That becomes a, so let me show you. Malit, you didn't send, huh?
Just give me a second. I'll find the argument of the here.
Yeah, this is Nathan's. That's correct. And this is right where the that's where the Z is with the largest argument. And you can all see, you all can see Nethni's, not Nethni's. Is it Nethni's? Yeah, Nethni's in the group, which is this same thing. How do you find that argument? How do you find that angle? So let me leave that. It's just, we had the same question in a previous question. We had the same thing to find in a previous question, how to find that angle. We all understood why that Z is right there, where the tangent touches the circle. That's the point, who has the largest argument. But how do we find that angle is another question. And so let us take it up tomorrow before we discuss the...
Miss, I think I found the answer for that.
You found? How much?
Let me see, 1.8. Hold on. That is 131.8.
Could be right. Can you tell us? No, don't tell us. Don't tell us. Let the others think also. Okay. Shall we take it up tomorrow?
Okay.
How to find
Okay.
two things. How to find that largest argument. And in one question we had how to find the shortest modulus.